What's up guys, welcome to my channel. This video I want to solve this stoichiometric question. It says how many liters of hydrogen gas will be produced at STP or standard temperature pressure from the reaction of 3.786 times 10 to the power of 23 atoms of magnesium with 28.21 grams of phosphoric acid. Okay, the first thing I need to write the chemical equation of this reaction. So it will be Mg plus H3PO4, which is the phosphoric acid. It will produce Mg PO4. Mg is 2, PO4 is 3. So it's going to be Mg 3 PO4 2 plus H2. Then I need to balance it. Mg is 3 here, here is 1, so I'll make it 3. PO4 is 2, here is 1, so I'll make it 2. So how many hydrogen we have this side? We have 2 times 3, 6, and we have 2 here. So if I put 3 here, it's gonna balance it. So now the equation is balanced. So first of all, I need to find out the number of moles of magnesium and number of moles of phosphoric acid. So you know 1 mole contains 6.022 times 10 to the power of 23 atoms. So right now we have 3.786 times 10 to the power of 23. If we divide it by 6.022 times 10 to the power of 23, these two cancel out. And then I can say 3.786 divided by 6.022, it will be 0.628. Or if you round it, it's going to be 6.629. So that's going to be the number of moles of magnesium. Mg. Now I need to find out the number of moles of phosphoric acid. Phosphoric acid H3PO4 is 3 times 1 plus P is at atomic mass of phosphorus. I forgot to write it down. Supposed to be 31, or it says 30.97. Let's round it to 31, so it's going to be 31 plus 4 times 16 for oxygen, so it will be 3 plus 31 plus 4 times 16, it will be 98 grams per mole. So the number of moles of H3PO4 or phosphoric acid is 28.21. That's the grams, divided by this one is, so we have 0.288 moles of acid. Okay, so now we need to look at the ratio to find out which one is their limiting reactant, which one is excess. If we have 3 moles of magnesium, it will react with 2. So it means that the number of moles of magnesium must be 1.5 times the number of moles of acid. So here number of moles of acid is 0.288. And the number of moles of Mg is 0.629. So let's find out the ratio. That's 2.18. So it is more than 1.5. So it means that we have excess magnesium. So magnesium is going to be excess. and acid is going to be the limiting reactant. Alright, so, and the calculation will be based on the limiting reactant. So we have 3 mg plus 2, I just write it again, gives you mg3 PO4 2 plus 3H2. So the limiting reactant is acid, and we have how many moles? We have 0.288. Now I need to figure out how many moles of magnesium it will react. So I just do cross multiplication. X 2x, 2 times x equals to 3 times 0.288. So x will be 3 times 0.288 divided by 2, which is 0.432. That's number of moles of reacting magnesium. Alright. So the question didn't ask for it, but I wrote it anyways. Here, this part. Only this part. So we need to find out how many liters of hydrogen gas it will produce. So we check the balance. It's 2 and 3. The ratio, 2 moles of acid produces 3 moles of hydrogen. So actually I wrote it for magnesium. Since they have the same coefficient, I can use the same number. So it will produce 0.4232 moles of hydrogen as well, because the coefficients are the same here. So we have 0.432 moles of hydrogen produced, and the molar volume at standard temperature and pressure is 22.4. I multiply it here. It will be 0.432 times 22.4. It will produce 9.68 liters of hydrogen. So that's gonna be the liters of hydrogen gas produced at standard temperature and pressure. So that's the final answer. Please leave me a comment if you have any question. I hope you like this video, and please don't forget to subscribe my channel. Thank you.